Pre-calculus students and seekers of truth, let us talk about another intuitive concept that can get tricky some of the time. And this is a local minimum and local maximum, absolute minimum and absolute maximum. So let's start with the definition. A function f of x has a local minimum at x equals c if there is an open interval. And so some words here that we need to make sense of. Open interval basically just means that it's some sort of region on the graph. Okay, I'll define this more clearly in a little bit, but open interval here just means some region on the graph where f of c is less than f of x for all values of x. So f of c is a specific point, f of x is any point. So this is saying a specific point is smaller than any other point. So for an example here, if we look on this graph, at this point we see that this point is smaller than every other point. So c here would be 4.9. And so at this location, f of 4.9, which is negative 4.81, but we can see that f of 4.9 is less than or equal to f of x, all other points of x. Okay, so this is what we can say is a at least a local minimum. This point here at 0, f of 0, is also a local minimum because for some open interval, and let me talk about a little bit more of that now. For some open interval, so if I can draw like a region around here, like around there, right, between -1 and +1, there is no other point smaller than this, okay? In that particular region. There is no other point smaller than this point. Now, if I expand the region, then I might get some smaller point than this. But in this region right here, there is nothing smaller than there's nothing lower than this point right here. Similarly, a local maximum is a point where f of c is greater than f of x. So if I move this region, if I look at sort of right around here, then in that region, this point here is the largest point that you could be in. If I expand this region to be bigger, then we might find some bigger points, but in this little area, this little region, that's the largest point that you can have. A minimum is absolute if it is smaller than or equal to every number in the interval. So let's go back to this region here, and let's look at an example. In this little box here, f of 0 is a minimum. So let's write down some terms here. So f of x has a local minimum at 0, 0, at x equals 0. So when x is equal to 0, f of x has a local minimum. Now, on the interval, and when I say interval, we're talking about intervals of x, and we're talking about all inputs. On the interval -1 to +1 only. So if I talk about just that interval from -1 to +1, f of x has a global maximum. A global minimum at x equals 0. So if I look at just this region only, then this point right here is the absolute smallest that I can have, that I can get. Now, if I decide that I want to widen my range a little bit, if I want to expand this interval, so if I go all the way out to here, then f of x still has a local minimum. The local minimum doesn't change. around here, there's this f of 0 here is still the smallest point. But now that I have widened my interval all the way to x equals 4, there is some other point that's smaller than that. Okay? So let's talk about that a little bit more. So on the interval -1 to 4, f of x has still only a local min at x equals 0. So this point here, it's still a minimum in that little region, but now that I've expanded my interval, I'm considering everything from -1 to +4. That's no longer global. There's some other point, namely over here. This point here is smaller than that one there. So this is terminology that will be important and we'll apply a little bit later on. But when we're talking about min and max, basically min is the smallest number that you can have in that particular interval, and max is the largest number that you can have in that particular interval. And it's global, or the point is either a global or a local, depending on which interval you're talking about. If we look at the entire domain of f of x, if you look at the entire domain, so if I were to, let's say, get rid of this box right here, and if we were to look at the entire domain, which is from -infinity to +infinity, then f of x has no global or local minimum or maximum. So if we consider that this graph goes down here forever like that, and it goes up this way forever, then for -infinity to +infinity, f of x has no global min or global max. No global min or max. Because on the entire interval from -infinity to +infinity, this graph is going to go down forever. There's not going to be a smallest number. There's, obviously, you go up this way, there's not going to be a largest number. It's just going to keep on going forever. It will still have some local ones. This is a local min. That's a local max. This right here is a local min. This up here is a local max. That's up here too. This is this. Let me do that again. This is a local min. This is a local max. This right here is a local min. This up here is a local max. Okay? But on the entire interval from -infinity to +infinity, it has no global min or max. So it depends on what interval we're talking about to determine whether something is local, is a global min or max. One more phrase that we should get the hang of using is the word extrema. Okay, so extrema is a catch-all for min or max. So whenever I ask you find the extrema, that means I'm looking for any of the minimum or any of the maximum on a particular interval. All right, so we're using the same graph here as we did from the last time, and you can see also one more time that if you have a point that is part of an increasing interval and a part of a decreasing interval, then it's going to be an extrema. Okay, so from what we talked about up here, remember that -2.06 is part of an increasing interval, and it's also part of a decreasing interval. So that means when x is equal to -2.06, f of x is going to have an extrema. And depending on what the graph looks like, it may be a min or a max. Okay, so these two concepts of increasing, decreasing, and extrema, they're very much related. All right. As always, thank you for watching. Ask for help if you have any questions, and have a wonderful